Hi, my name is Ray Austin with Austin Air Company. I'm a small HVAC company located in Katy, Texas. I service the Katy, Texas area and some surrounding areas. Today's topic is going to be new air conditioning Freon phase down, part 2C. This is the third part in the Refrigerant Wars heading of this new air conditioning Freon phase down. There are additional links in the description. If you somehow stumble across this video and you haven't seen the previous parts, I'd recommend that you stop this video and watch the other parts first. This is the third part in the Refrigerant Wars heading. And so the Refrigerant Wars has been subdivided into parts 2A, 2B, 2C. This is going to be part 2C. So if you haven't watched the previous versions, I recommend that you look down in the description and go to the corresponding part that you want to watch. So with that said, we're going to get started. I'm going to dive right into this. Stay tuned. So we get into manufacturers that are going to use R454B as future environmentally sustainable refrigerant solution. Johnson Controls, they're really a smaller type manufacturer. I mean, they make York, Coleman, and so they're really a smaller type of manufacturer. Occasionally, I'll go there to get parts and things of that nature, but usually they've gotten into microchannel technology, and so for my climate, which is a very hot climate, as I've already said, probably more than once. And so I don't get into microchannel because there's complications. I just don't view microchannel as a good fit for my climate. We use our ACs here 9-10 months out of the year, and I just don't view microchannel as something that great for a hot climate that literally depends on air conditioning. So moving on, Carrier is probably one of the biggest manufacturers there are. They make more brands than any other manufacturer that I know of. But a brand is a brand is a brand. I mean, they essentially do pretty much the same thing, unless you get into the higher efficiency ratings. But then there's cons, related to that. And so, and this was dated January 2. I mean, they came out pretty much right away. I mean, they were one of the first manufacturers there, and Carrier was pretty much behind the push to R410A. When R410A came out, they were pretty much head over heels involved with that. They had tested a bunch of other different refrigerants. So if you were an early adopter with Carrier, during that time period, this would have been in the late 90s, early 2000s, and so there was a lot of issues to contend with then. I worked for back in that day. I wasn't licensed. I was a technician working for a large HVAC company, and so I saw a lot of that stuff firsthand. I worked with R410A back in the early 2000s when it first came out, so I'm quite well versed in knowing when refrigerant phase outs start coming. I know the complications involved with a lot of this stuff. And I can see things, coming right now that are going to be a game changer. I mean, people are going to just be, they're not going to be happy. I can tell you that right now. Let me tell you, I've been in some homes, back when we made these changes, and not saying that they were always doom and gloom, but there were some where we had some issues to work out, to say the least. So after extensive tests and evaluation, Carrier has identified R454B to be known commercially as Puron Advance. Yeah, good luck with that. We don't even call Puron Puron. We call it Freon. So good luck with us calling it Puron Advance. I mean, that's just too many syllables for us to exhibit. Yeah, it's much easier to just call it Freon. As its primary lower GWP solution to replace R410A and all of its ducted residential and light commercial package solutions sold in North America. New refrigerant to be offered in these Carrier products beginning in 2023. Yeah, I mean, we're talking next year, is expected to surpass the requirements of anticipated future regulations. Yeah, for maybe a decade. Carrier will select the best suited refrigerant for other applications as the need arises. So, Refrigerant Wars, that's the title of this video. Refrigerant Wars are coming. Buckle up. Carrier has been working with the Chemours Company, a global leader in fluorochemicals and refrigerant technology, which will produce and distribute the new refrigerant under the name Opteon XL41 in North America with a GWP of 466. Yeah. So, we'll leave it at that. I mean, Chemours Company is a refrigerant conglomerate. They essentially bought the rights to the name Freon. So, and DuPont is the one who put that on the lips of every American from here to the Mississippi and up and down and south and so I mean it's not going to change anything. I mean, people are going to continue to call it Freon. There's nothing you're going to do to prevent that. No matter what other brand name they come up with, people are still going to call it Freon. So. And I've given up on that battle a long time ago. It's easier for me to just call it Freon and just, I know what it needs. So that's the important thing, is that I know. You certainly do not want to get somebody to your house that does not know. That is another key point in this video. If you're not using somebody you trust, you're in deep caca. Okay, so moving on. Trane, chart 15, sustainable refrigerant spotlight on R454B. So Trane is an interesting manufacturer because they go a little bit better in the truth department, because they make comparisons to the other refrigerants, but there's some hyperbole because R54B is an interior refrigerant. So, I mean, it's not perfect by any stretch of the imagination. And so, but I put this out there because Trane at least is slightly more truth-telling than some of the others. So, I spent some time digging for this info. I have a way of finding the truth. These choices will all be undone in probably another decade, maybe less, just in time for you to rip out your old unit for another one. Because this is an interior refrigerant and it's going to be phased out. So this next chart gets into it somewhat. R454B is the lowest GWP value option to replace R410A with a GWP decrease of 76% and 34% lower than R32. These are all correct statements. They're true. The only con is that if you spring a refrigerant leak, R454B, that unit is going to cost you more to repair it. Period. Plain and simple. Because the refrigerant costs more. There is a 10% penalty, meaning that whatever unit you decide is going to have 10% more refrigerant than an R32 comparable size unit. But with at least Trane doesn't hide the other choice, that being R32, and showing the comparison to R410A GWP figures. I mean, they're pretty accurate. The R410A, though, of what they show is less than the information that I've found elsewhere. I mean, it's typically over 2,000 GWP. So, I don't know why they're coming up with this 1924 figure for R410A. Everything that I see is up over 2,000. So one thing to consider is if R32 total charge is 20% less than a comparable R410A machine, and R32 total charge is 10% less than a comparable R454 machine, and R32 costs less and marginally more efficient, 1 to 2%, all those nickels and dimes add up over time, especially considering this solution is only an interim solution. It's not a permanent solution. You're going to be ripping this stuff out again. So why spend more money for something that is only an interim solution? We're going to get to it. So chart 17, lower operating costs. Our units with R454B are competitive versus legacy Trane products. Now realize when they say that their units are more efficient with R454B, they are comparing the efficiency to an R410A machine, most likely. Because they don't say that they're comparing it, they're saying legacy. What is legacy? It's the previous refrigerant. 1 to 5% more efficient. And other products on the market. In addition, because we chose the lowest GWP available and reduced the total refrigerant charge volume, realize it's 10% less than the legacy R410A refrigerant. But R32 is 20% less, and it costs cheaper because it doesn't have any patented refrigerant needed to produce it. So how does all this take shape? Now, Trane is being really truthful here, and I applaud them for this because it really just paints the picture as to why they chose what they chose. It's not necessarily beneficial to you. It's beneficial to them due to how governments are setting tax schemes and subsidy programs based on GWP values, meaning of the refrigerant that a particular manufacturer is using. By investing in a lower GWP, meaning you're spending money because you're investing in this GWP, you are reducing your cost of future refrigerant purchases. How? How are you going to reduce the cost of your future refrigerant purchases by spending more money? You're not. This is where they're duping you. They're making you feel good with feel-good sentiment. And the difference between R32 and R454, it doesn't matter. R454B is going to be phased out just as fast as R32 is. The difference is cost. What is it going to cost you? We don't know. And one thing to realize is that air conditioners, typically anything made within the last, I'd say 5, 6, 7, 8 years, it's not uncommon for me to see a coil failure within anywhere from 3 to 5 to 8 years, sometimes maybe a little bit longer than that, but usually within that realm. Anything made, I would say probably 2015, 2016, and earlier. Typically I see, refrigerant leaks and coils on a fairly consistent basis. And a lot of times it's usually in that 5 to 6 year range. Not always. Sometimes I've seen it as little as a year, year and a half, 2 years, 3 years. So it varies, from one house to the next. So that's all we're going to touch base on that. It's primarily cost, because that's really what's driving everything. So that brings us to chart 19, picture 19, and I was really surprised to find this information. I really researched this subject quite well. There's a limited amount of information available. So this figure 13 R290, I've already discussed R290. It is propane. Just realize that this R290, that R in front of it stands for refrigerant 290. So in other words, it's a refined refrigerant gas, meaning, it's not the same thing like if you go down to the local store and you go buy a propane tank, for your grill. Because there's additives added to that to where if you spring a leak or something, you can smell it. R290 there is no smell to it. and it's refined, it's pure R290. There's no additives added to it. And so that's what makes it dangerous, is because you'd have to have some sort of alarm system on your person to know if there's a plentiful amount of R290 in the air. And so, but I'm not really going to go into that. I mean, the technology exists to make this doable. The problem is cost. It's going to take you a huge leap in order to get to this realm, and everything would have to be reworked, because a common place for current systems to leak is in the evaporator coil, which is typically a foot to 2 feet away from your furnace, which essentially is an open flame when you're running the heat. And so that poses problems, because R290 is an explosive, highly flammable gas. And so there would have to be a reworking of your HVAC system in order to get this to work. Now, essentially how they could get this to work is, if you look at the chart, you'll see that the outdoor unit has an expansion device, has a condenser, has a compressor, and the evaporator section is cut in half. And essentially what that means is that there's another intermingled evaporator section filled with a fluid. It's like it's essentially a chiller, basically. And the chillers today are usually made for large industrial type, schools, commercial buildings, and so on. And so, but you would, in order for you to use R290 at your house, your whole HVAC system would have to be changed out, and you would need a kind of like a glycol-based type medium that would interact with the evaporator coil outside in that outdoor account. And I'll highlight the parts that I'm talking about on the screen, so you understand what I'm talking about. But essentially, it would work in the way of a chiller, and you would have a glycol solution that would be pumped up to another coil that's attached to your furnace, like your AC is now. But it would probably be a different type of I mean, they could potentially make it out of PVC, potentially. I mean, as long as it's got the characteristics of absorbing heat from the structure. I mean, essentially all you need is a 40-degree glycol-based solution running through there, and essentially it's the same thing as an air conditioner. It runs at about a 40-degree coil. But the thing is that by having that glycol solution, you would get specialized training, and you could essentially put that coil at pretty much whatever operating temperature. So you'd have the ability to design it and put that temperature wherever you wanted. I mean, if you wanted a 50-degree coil, you go to a 50-degree coil. If you wanted a 35-degree coil, you go to a 35-degree coil. Obviously, there's pros and cons to doing that depending on the climate in which you live. But those things would be attainable. One thing to note, you got the pros over on the other side. They say, the refrigerant is isolated in a self-contained outdoor unit, meaning the R290 does not enter your home. So if you spring a leak out there, it just leaks into the air, and it's less likely to pose a problem. One thing you got to realize, in America, out in the rural areas, you've got propane tanks sitting out in your backyard. They use it for propane, for propane furnaces, gas cooking, gas dryers, and so on. It's a plentiful natural refrigerant. Can use A3, 290, R290, or whatever. Meaning that you could then use whatever refrigerant. Potentially maybe even use carbon dioxide at some point once that technology. But there's a lot of complications in terms of carbon dioxide ever being used as a refrigerant for residential. So, that's far and away down the road. I think we use R290 before we ever consider using carbon dioxide. There's just too too many complications and extremely high pressures. I just don't see it. So one thing to note about R290 is the pressures, the operating temperatures in which it runs is very similar to R22 Freon. There's very little, if any, difference in terms of pressure. So yeah, I mean, so if you've got technicians that are accustomed to using R22, I mean, it's just the safety aspect and wearing wearing a gas detection meter and using proper protective equipment and so on. The other benefit in using R290 is that it would make people think twice before they get on something not knowing what the heck they're doing, because an explosion would be imminent. The other pros is that you've got the elimination of direct expansion evaporator superheat. Short refrigerant lines, less superheat, less pressure drop, less refrigerant. You don't need as much refrigerant. Better oil return management, multi-zones, indoor hydronic without added refrigerant. Easier to integrate water, heating, and thermal storage. More uniform indoor air temperature with hydronic. And hydronic is essentially water, but usually it's a brine solution to prevent freezing, in certain areas of the climate. You don't want that solution to freeze. More uniform indoor air temperature with hydronic. You can select more optimized coolant, e.g. CO2. I don't think, that's anything that we're going to get into anytime soon. I mean, that's really just looking way far down the line. And what would be the need? I mean, R290 is plentiful. It's not what I would consider expensive. And so, I wouldn't see the reason, other than maybe efficiency, but, I just don't see it. CO2 has just got a lot of challenges to it. Optimize hydronic coil design for higher temp, meaning, that you could have a higher temp coil, 50 degrees. Certain applications, you may want that design. You may want a lower temp, but obviously, you can't go much lower than probably about 35 degrees. I mean, it doesn't make sense to do that, because at some point, if you're in a humid environment, the humidity starts to freeze on the coil, and so it's counterproductive. So there's a limit. There's a limit to that madness. Can be air to water heat pumps similar to Europe. Cons: pump and secondary HX, efficiency loss and cost, pumping loop valve expansion, tank control, on-off cyclic performance delay. So essentially what that means, if you don't run the equipment that much, but essentially, I mean, for Texas, like, say for example, you shut the unit off. Typically, I mean, you're looking at 4 hours for the equipment to cool down. So I don't view that as a con. I mean, that's something that we deal with now. I mean, if I'm out there repairing your AC and then I get done with it, we turn it on, and it's a hot day, it's going to take time to pull down. So, that's really just nonsensical in my opinion. But I live in a hot climate, so there's a lot of things that I deal with that some other climates probably are less accustomed to. The other con with this modification is that you get into like smaller dwellings, like apartment complexes, and so sizing becomes an issue. I mean, you've got to have the flow rate, because that medium that you're using to extract the heat out of in that loop in the outdoor unit, it has to be sufficient. And so if you're living in an apartment that's maybe 800,000 square feet, it's a much smaller unit internal, and so there would likely be complications to try to retrofit those kind of applications. And so under those circumstances, I believe, that would probably be more likely to go to like a mini split type, and use a traditional refrigerant. And part of that is to, these bigger structures that we're building, homes. I mean, it's not uncommon for some homes to have 2, 3 units. And so imagine, being able to size a unit larger than what current manufacturing allows you to do for residential. Meaning that, if you've got 4 tons for the downstairs unit, you've got 4 tons for the upstairs unit. Imagine being able to just put in one unit, 8 tons. You twin the furnaces together to produce 8 tons of airflow, and then you include the glycol evaporacool that cycles that stuff through there. You could essentially cut your equipment costs, and trying to recoup some of this retrofit design. But I think R290 is the wave of the future. I mean, it's already there. They don't have to spend, time and energy trying to look for a refrigerant that may not exist. I mean, they've already stated that, there is nothing in terms of non-flammability that's going to work. It's going to be mildly flammable, this or that, but I mean, we've already got a refrigerant that's plentiful, natural. What more could you ask for? But the problem is money. It's you're either going to pay for it in retrofit costs, or you're going to pay for it in refrigerant production costs. There is no simple way around it. But that doesn't mean they're not going to try. Which leads me to this next statement. Daikin looks to replace R32 in 2023. There's a picture of a Daikin CEO. As I've said previously, Daikin is a parent company of Goodman Global, manufactures Goodman, Amana, and Daikin for North American HVAC market. Also is a manufacturer of R32 refrigerant. Masanori Tagawa, developing a groundbreaking refrigerant. Japan. Daikin hopes to introduce a low GWP refrigerant replacement for the current R32 in air conditioners in 2023. There was an update 28th of May in 2019, Daikin R32 alternative some years away. Announcing the air conditioning manufacturer's latest financial figures last week, President and CEO Masanori Tagawa told Japanese journalists that the company was employing AI, artificial intelligence technology, to develop a new refrigerant with a GWP of 10 or less. This, he hoped, would be introduced in 2023. Now, if this happens, this plays right into my hands of this video being Refrigerant Wars. Because if they somehow pull a rabbit out of the hat, this is going to throw the North American refrigeration market into a tizzy, because all these other manufacturers are getting on board with this R454 change out, and Daikin would then be in the forefront if they somehow pull a rabbit out of the hat and develop a mildly flammable A2L replacement for R32. Could they do it? I don't know if they will or not, but this is just one more clue and one more benefit to you for watching this video all the way to the end. Do I know what will happen? No, I'm not a psychic, but things are heating up, and so we don't know until we know. But that would change the game if they somehow pull a rabbit out of the hat and they come up with a refrigerant that hits all the bells and whistles that's needed currently. And then, if they do get down to a GWP of 10 or less, then we don't need to worry about the R290 thing, But I think R290 is likely in our future in some form. Which leads us to the last little tidbit. This just hit Saturday, April 23rd, 2022, off of Yahoo Finance, Fortune magazine. Companies are beginning to panic. Oh, imagine that. 2022, companies are beginning to panic. Oh. Experts say China's lockdowns will make inflation and the supply chain nightmare even worse. Ruh-roh. How could it get any worse? I can't get the equipment now. I can get it, but in some situations it takes a lot of challenge and a lot of trouble. So, can't get what you want. China lockdowns signal things are only going to get worse. If you can find what you want, you better buy it. And you better buy it before someone else. Or you may have to do without. So essentially, there hasn't been any more announcements, as of this time period. The closer we get to 2023, things will become more clear. I thank you for watching the video. What do you think is going to happen? Maybe you have some insight that maybe I don't. Leave a comment in the comment section. I will include a link to part 1 of this video in the description, and I may even put some other late breaking info should some information become available. I may post some links in the description of this video. Please like and subscribe the video, get the word out. If you live in or near the Katy, Texas area and you're having air conditioning problems and concerns, you can give me a call at 832-475-6895. Or, for more information, you can always visit me on my main website at www.austinairco.com. For Austin Air Company, my name's Ray Austin. I hope your day is comfortable. Thank you. So if you live in the Katy, Texas area, you can give me a call at 832-475-6895. Or for more information, you can always visit me on my main website at www.austinairco.com. For Austin Air Company, my name's Ray Austin, and I hope your day is comfortable. Thank you. I don't know who you are, but I know that you're probably trying to run your AC lower than 78 degrees. You might even be trying to mine some bitcoins on our fragile Texas power grid. That is going to cost you. I cannot save some gas by buying an EV to hog even more power from our poor little Texas power grid. But what I can do is apply my knowledge and a unique set of skills. Skills that I have acquired over a very long HVAC career. Skills that can put an end to your discomfort if you stop hogging excessive power that is going to bring down the Texas electrical grid. If you tell me where you are, I will find you. I will not stop until I find you. If the power is out, call Centerpoint.